Welcome to EDU World Space.
So a patient is injected every 12 hours, and then immediately before the injection, the concentration of the drug in the body has been reduced by 90%, and then the new dose, an increase, is about 1.5 milligrams. So here, and if we want a picture for this, it looks like we're letting Cn equal the concentration. So here we have our units, milligrams per liter. This is after N doses. Now let's go ahead and just draw a graph here. We start off with no dose, and then after the first dose, we go up to 1.5, and then after that, we decrease by 90% over the next 12 hours. But then, right at the hour, we have another increase. So C1 would be 1.5. C2 would be, well, right before we get to the second 12-hour period, the end of the period, we'll have reduced by 90%. So that means that we'll have 10% left of previous dose, of previous concentration. So 10% left, that's just 0.1 or just 1 over 10. So C2 is just C1 over 10, but then we also have to add in the increase 1.5. So this is just 1.5 over 10 plus 1.5. So 1.5 plus 0.15, and that's 1.65. That's C2. And then we'll do this one more time. So at C2, if we want to draw that on the graph, we can see that it does a jump. And then, once again, from the 24 hours to the 36-hour period, so the third 12-hour interval will decrease by 90%, and then once again will increase by 1.5. So C3 is just 10% of the previous concentration plus 1.5. So by our answer over here, that'll just be 0.165 plus 1.5. So that's 1.665. That'll be the answer for part A. That's the concentration in the body right after 3 doses. So there's where it is graphically. C3, and this up here are Y values, so it's just Cn. So now let's go on to part B. Cn, as we've denoted, concentration in the body after the nth dose. Let's find a formula for Cn, but this time as just a function of n. In part A, we've kind of been using the formula. Let me go to the next page. Cn equals Cn minus 1 over 10 plus 1.5. This was the formula that I was using in part A to find the concentration for the first 3 values. It's given by the fact that before the new period, we'd have only 10% of the previous dosage, but then we also increase by the 1.5 each time. But now in part B, they want a formula to depend on n only. So not Cn or Cn minus 1, etc. So what we can do here is just keep following this pattern. So if I use this formula again, I can replace Cn minus 1 with this term up here, and then I divide that by 10, and I add the 1.5, so let me color coordinate here. These are the same. and then these are the same. And I can go ahead and rewrite this out. So perhaps we can just keep following this pattern, and then n times, that depends on n, so we should end up with a formula that only depends on n. So let's just keep following this pattern. If we keep following this pattern, well, eventually we'll get down to C1, but what should the denominator be? Well, notice that these terms right here add up to n. So if I have a 1 here, then I should have an n minus 1 down there, so that they add up to n. And then we can see what looks like a geometric series, 1.5, 1.5 over 10. That should not have been a 10 squared. That should have been just a 10. Sorry about that. Let me go ahead and erase that. Oops. So if I keep going in this pattern, what will the power of 10 be? So we started off with n, then down here it goes to, let's see here, n minus 2. So it's always 1 less than the power of 10 over here under the Cn. So if this is n minus 1, then this must be 1 less than that, so n minus 2. Now I can go ahead and use the fact that C1 is just 1.5 after the first dosage. So I could go ahead and rewrite this as 1.5, and then I can see that this sum is just 1.5, 1.5 over 10, all the way up to 1.5 over 10 to the n minus 1. So we have all the powers. So now this is a geometric series. I'm running out of room here, so let me go ahead and write this on the next page. So this is a finite geometric series. And it can be simplified now, but there's no need to. It'll actually be easier. And so this is part B. Let's just leave that as it is. It can be simplified. There is a formula for finite geometric series, but there's just no need to use it here. We can see the right-hand side only depends on n, and we can actually use this to answer part C. So for part C, they wanted the limit of Cn. So let's go ahead, and if I take the limit of this as n goes to infinity, well, that's just this infinite geometric sum, and we have an easier formula for that. This is why I would rather just go to infinity first and then use the formula. Because now we know the formula is first term over 1 minus our common ratio. So here, that's our first term. And our r is equal to, what are we multiplying by each time? Just 1 over 10. So we'll have 1.5 over 9 over 10. So that's 15 over 9. And we could even simplify that to 5 over 3. So that's our answer for part C. That's the limiting value of the concentration after n values. And that's our final answer.